So up to this point, we've been using logarithms to solve logarithmic equations, but we've never really seen what the purpose of a logarithm is besides to do these operations. Today we're actually going to be applying it in its need and why they're around sense. And so we're going to be solving exponential equations using logarithms. That's the purpose of a logarithm, is to get to the variable in the exponent and solve when there's more than one operation. And so if I give you a problem, 3 to the 2x minus 7 equals 81, can we identify a way to solve this without logarithms? Can I raise 3 to a power and come up with 81?
Yes.
3 to the what power? Does anybody remember? 3 times 3 is 9.
4.
Times 3 is 27. Times 3 is 81. So 3 to the 4th. And so to solve this equation, these exponents would have to be the same. 2x minus 7 would have to equal 4 for this to work. And if I needed to solve this, I would add 7 to both sides, giving me 2x is equal to how much? And divide by 2. And so x is equal to 5.5 or 11/2. And so when there's a way I can raise the other side to match, I can solve these without logarithms. Is life always that simple?
No.
Most of the time, no. And so like here, is there any number I can raise 7 to that's a whole number that we can think of that would get us to 42? No. And so it's going to end up being a crazy fraction to help us get there. And so for us to solve for that exponent, we need to get this exponent by itself. And so the only way we have to get into that exponent is using a log. So we're going to use the fish to help create the log. So it's going to be log base 7 of 42 is equal to negative 5x. Now we're going to divide both sides by that negative 5 because we need to get x by itself when we're solving for x. And our final answer is negative log base 7 of 42 divided by 5. All I did is move that negative to the front. I'm done. For tonight's assignment, or for this assignment, we are going to leave in terms of log. If we need to know a decimal, what do you think we could do to find a decimal? Plug it in the calculator and find the number. So that's our answer for today. So here, what is different? It's an e. So what's log base e? What's another way of doing that besides log base e? How would I write it? Anybody remember what log?
Just log 10.
It's not log 10. It's the natural log. That's the ln. So when we fish this one, we're going to end up with an ln because that's log base e. So we're going to fish it again. So log base e is natural log of 37 equals x minus 7. Now, how will I get x by itself? What do I need to do? So does this become ln of 42? No. We're adding it to the natural log. So that natural log of 37 is actually a number. We're adding it to that whole thing. So it's going to be ln of 37 plus 7 is equal to x. And you can write it this way, or ln of 37 in parentheses itself plus 7. Those are two good ways of writing it if you're going to be putting the number at the end. Do we have to write the number at the end? These are all the same thing. It's just me rearranging how it looks. So if you have troubles where you're afraid that I'm going to mistake it to where don't know where your 7's being added to, you can write it in the front, if that helps you. So let's do 2 more. These 2, we're going to have an extra operation. We're going to have, up to this point, we've only had the exponent problem set equal to a number. Now we have another operation. And so we need to first get the exponent portion by itself. This portion needs to be isolated first. So what would I need to do that? Add 5. Now this time, will that 5 change the number?
Yes.
And that will become? 77. So 6 to the x plus 4 equals 77. What do I do next?
You fish it.
And so we end up with log base 6 of 77 is equal to x plus 4. And so now I need to move the 4 by subtracting. That can't change that 77. That 77's locked. And so we have log base 6 of 77 minus 4 equals x. The last one, and then I'll let you work on the assignment. What operation's attaching something to that exponent problem? Multiplication. So to undo it, we need division. So we're going to divide both sides by 10 or 7. We divide it by the number that's being multiplied to the exponent portion. And so 10 to the 4x is equal to, does 7 divide evenly into 38?
No.
Can it be reduced?
Yes. I just
Is there a 7, what are the factors of 7? They can, 1 and 7, right?
Yes.
So no.
No.
It's in simplest terms. So you're going to leave it as 38 divided by 7. Always check to make sure it can't reduce. Now, what do we need to do next?
We need to add 7 to get fishes.
We need to fish it. Because we have the exponent is equal to a number. So log base 10, do I need to write the 10? Of 38 sevenths is equal to 4x. Now how do I get the 4 away from the x? So log base 10 of 38 sevenths divided by 4 is my answer.